Okay, so today I'm going to solve the equation. This topic is about discriminant. Actually, the idea of discriminant and quadratic equation and the number of solutions. So the question is this: the numbers x and y satisfy the equation 4x squared plus 16xy plus y squared plus 16x plus 14y plus 13 equals to 0 if a real value of x is substituted into the equation. The equation becomes a quadratic equation in y. What is a quadratic equation in y? A quadratic equation in y simply means that the highest power, this is the equation with an equal sign, is the equation, highest power of y is 2. That means it's a quadratic equation. Now given that two distinct real values of y, distinct real values of y may be found from this equation, show that 5x squared plus 8x plus 3 greater than 0, and hence find all set. Okay, hence find set of possible values of x. Now, first thing, what is a quadratic equation? A quadratic equation is something of the form ax squared plus bx plus c equals to 0, and the solution for x in this case would be the standard formula: x equals to minus b plus minus square root b squared minus 4ac over 2a. Now, depending on what is our b squared minus 4ac, we could have one root, we could have two roots, or we could have no roots. What do we mean? Now, first thing we need to explain what is real values. Real values is actually all real numbers like 1.2435. This is a real number, this is 1. Integer are also at the same time real values, but real values are not integer. Integer are 1, 2, 3, 4. All these are also real values. That decimal integers we also decimal place. Numbers that with decimal place are also real numbers. In fact, pi with an endless string of number is also a real number, so is E1. So all real numbers are real numbers. What are not real numbers? We have complex numbers like x2 plus 3i. When there's this I symbol, which means I equals to root minus 1, when this happens, this is not a real number, this is a complex number, this is an imaginary part. We only learn the meaning of know the meaning of real number when we see complex number, because the only number that is not real are complex numbers, right? That with this imaginary I. So now let's see what happened. When you can't square root a negative number. Let's say if you square root a negative number, you get a complex number. So you cannot have a real number by square root a negative number. So that means what? That means, let's say if my b squared minus 4ac smaller than 0, which means that b squared minus 4ac is a negative number, then square root b squared minus 4ac is not a real number. It's not a real number, so there wouldn't be if b squared minus 4ac is smaller than 0, then there wouldn't be a solution for this equation. There will not be a real number solution for this equation. You could get a complex solution for this equation, but you will not get a real number solution of x for this equation. So now What if my b square minus 4ac is okay, no solution, no real solution, and my b square minus 4ac is greater than 0, we have two real solutions. Why two real solutions? Because let's say if we substitute if b square minus 4ac example equals to 3, and then we will have minus b plus minus square root 3 over 2a. So one of the solution is minus b plus root 3 over 2a. The other solution will be minus b minus root 3 over 2a. This would give us two real solutions, 1 and 2. Correct? Because plus minus here simply means one solution is plus, the other is minus. One is plus, one is minus. So then we will have two real solutions. What if our b square minus 4ac equals to 0? Then this part is equals to 0, square root 0 is equals to 0, and our solution is just x equals to minus b over 2a, and this is one real solution. That means when b square minus 4ac equals to 0, we have one real solution. Now, b square minus 4ac is also what we often call the discriminant of a quadratic equation. So this is the discriminant. So I will frequently refer this to as the discriminant. So now they say, given in the question, that two distinct real values of y may be found from the equation. That means which case is this? That means two distinct real solutions means our b square minus 4ac must be greater than 0. That means because there are two solutions. So this is the case that we want. But before we are able to apply this, we must know what is our b, a and c in this case. Now they say that when the real value of x is substituted, the equation becomes a quadratic equation in y. So we must reform this equation into one that is a quadratic equation in y. So how do I do that? So I just group all the y squared term together. There's no other y squared term, so I have y squared. So my a in this case is 1 times y squared, which is y squared, is a is 1. And what is my b? Plus I'll group all the y squared y term, because the coefficient of y is b. So this is b, and then the coefficient of the constant is my c. So 4x squared plus 16x plus 13 is my c. Okay, so then equals to 0. So given that two distinct real values of y may be found from the equation, that means b squared minus 4ac greater than 0. So I will write this 16x plus 14 square. Notice I'm not including this y. B is just the coefficient of y, not including the y. So b squared minus 4 times a, in this case a is 1, and c is 4x squared plus 16x plus 13 must be greater than 0. So we have this. So now I'm going to continue this question below. So 16x squared. So what is 16 squared? Now 16 squared is just 6636, 616, 96, 166, 111. So I got 256 here. Right. 256, because these two will add together. So 256 x squared plus 2 times 16, which is 32, 32 times 14, which is, because when you expand something like this, a plus b squared equals to a squared plus 2ab plus b squared. So the first term would square plus 2 times the first and the second term and the square of the second term. So now this one would be 2 times 16 times 14, and 2 times 16 32, 4, 2, 8, 4, 3, 12, 1, 2, 2, 1, 3, 3, and what I get is 4, 4, 8, and I must remember there's an x here, so 4, 4, 8 x, so plus 4, 4, 8 x plus 14 square, so 14 times 14, so 4, 4, 16, 4, 1, 4 plus 1, 5, so 56, 4, 4, 16, 4, 1, 4 plus 1, 5, 1, 4, 1 times 4, 1 times 1, 1, 4, so 196, so I have plus 196 equals to 14 square, so minus 4 times 4 minus 16x square, then minus 4 times 16 is minus 64x, minus 4 times 3 is minus 4, 3, 12, 4, 1, minus 52, so this is greater than 0. I'm supposed to show that 5x squared plus 8x plus 3 greater than 0, so I remove these workings first, right, so they have some space and it's not so confusing. And okay, so I just need to simplify this, since that my job is just this, so x squared term I cancel, 256 minus 16 is just 240x squared, and 448x minus 64, 448 minus 64, and 8 minus 4, 4, 14 minus 6, 8, and 4 becomes 3, 384, so I have plus 384x, and after this 196 minus 52, I got this, I'm trying to do this part, so 6 minus 2 is 4, 9 minus 5 is 4, and 1, 144, so plus 144, good. So far so good. So let's say what would give me 5, what would give me 3. So intuitively I let me see what divided 144 divided by 3 and 240 divided by 3, is there any commonality? So, and 240 divided by 5, I get 5, 4, 20, 40, 5, 8, 4. So that means I will need to divide by everything here by 48, and so if I divide by 48, do I get, so 240 divided by 48 of course would give me 5x squared. 384 divided by 48 would give me 6, 4, 24, 6, 8, 5, 7, 3, 8, 24, 3, 4, 12 would not, 6, 8, 48. What would give me 4 at the back? 8, 8, 64, 8, 4, 32. So 8, 8, 64, 8, 4, 32, 32 plus 6 is 384. So this would give me, that means, yep, I get 8x. And 184 divided by 40, 144 divided by 48, what do I get? 144 divided by 48, I guess it's just 3, 3, 8, 24, 3, 4, 12, 12 plus 2, 14. So I'll just get correct. This is exactly this. So this is exactly this. So I have proven. So now I'm asked to find the set of possible values of x. So possible values of x such that this equation has two values for y. So how do I get this? So now I can factorize this, right? If I do 5x plus 1 times x, no, 5x plus 3 times x plus 1, I should be 3 times 1 will give me 3, 5x times 1 will give me 5x plus 3x will give me 8x and 5x squared. So this is fair. So from here I would draw a number line to solve this inequality. This term will give me a value minus 3 over 5, because minus 3 over 5 times 5 will give me minus 3 plus 3 will give me 0, and this term would give me minus 1, and minus 1 is great, it's even more negative than minus 3 over 5. So I will draw this number line, doesn't matter, it's not so nice. So let's say next I want to know what region is positive or negative, right? So 0 is somewhere here in this region, 0 is somewhere, 0 is greater than minus 3 over 5. So to test whether this positive region is positive or negative, well, I just substitute 0 inside here. 0 when I substitute inside here, this term becomes 3 is positive, this term becomes 1 is positive. Positive multiplied to positive would give me a positive number. And since all of these brackets are odd power, the regions, the sign would just alternate. If one of them is an even power, then when we pass through the corresponding factor, for example -1 corresponds to this. So the power, if it's a square, then when we move through this point, the sign will not alternate but will remain the same. But since all of this power is power 1, which is an odd power, once it's an odd power, the sign will alternate when passes through the factors. So now since we want greater than 0, so we want all the positive region. So that means we want this region. And so because there's a greater sign over here, so we'll use the greater sign, minus 3 over 5, x smaller than minus 1. So we want x smaller than minus 1 and x greater than minus 3 over 5. So the answer to this question is this. The set of possible values of x is x greater than minus 3 over 5 and x smaller than minus 1. So this ends this tutorial. Okay, have a nice day.